Hello and welcome to another SAS Global Forum presentation. My name is Zoraya Cruz Bonilla. I work at Binghamton University as a data research analyst in the Division of Student Affairs. Today, I want to walk you through a few tips and tricks that you can implement in your own line of work to deal with submission form data, which, as you may already know, can be messy, might require a fair amount of cleaning, or must be manipulated in some way to make it more usable for analysis. These tips and tricks come from my own experience in assisting the Binghamton University Food Pantry. Therefore, while the presentation will provide concrete examples for handling submission form data, it will also spotlight the university's efforts to gauge food insecurity among college students. And given our current pandemic crisis, it has become even more critical to quantify unmet needs. With that said, let's look at the deliverables and learning objectives. Foremost, this presentation is appropriate for professionals who have had some experience with SAS Enterprise Guide, but would like to do more than just join tables and run basic queries. More specifically, anyone who wants to take full advantage of advanced tasks or functions and write a few lines of code all through the same point and click environment. At the conclusion of the presentation, you will comprehend the differences and similarities between two ways of combining data. You will become aware of built-in functions that extrapolate from datetime values. You will learn how to invoke and write code to capture the first stored observation in a group. And lastly, you will understand the utility of SAS Visual Analytics as a means for reporting meaningful metrics that stakeholders can respond to. So let's get started. You might be wondering from my opening slide, what is the Binghamton University Food Pantry? Briefly speaking, it is an on-campus service that was established as a temporary and judgment-free place for students that are facing hard times, such as running short of money for the month or facing emergency situations. In the university's efforts to identify and further support students who utilize this service, the food pantry has adopted several data collection methodologies over the past few years. Eventually, they landed on using Be Engaged, which is an all-in-one campus solution due to its event planning, communication, and workflow management capabilities. It was determined to be the best option, primarily because the system auto-populates the students' basic information, as opposed to relying on self-reported information, which, in the case of using Google Forms, lacked data validation controls. The Be Engaged submission form is divided into roughly 4 sections for students to fill out. There is an acknowledgement section, which students must check off on to certify their understanding that it is a service for students only. Second, there is an assessment section that the food pantry uses to ask general questions, such as, will this order provide assistance to a child in your household? The third section is intended to allow students to choose when they can pick up their food items within the hours of operation. The last section is for students to make food category selections. All these sections are rendered in the output CSV file. Also, as a side note, the form is refreshed every Friday, thus generating multiple CSV files per semester. The first step is to import each CSV file into SAS Enterprise Guide. And to bring everything together as one data set, the append table task must be invoked by clicking on Task, Data, Append Table, Add Table, select the imported files, and then run. One important caveat about this approach is that it is dependent on the column header name. That means that if the column header name changes, then SAS will treat it as distinct variables. In the example shown, all 3 weeks have a slightly different category name for produce. This is because food item availability varies from week to week, and the header specifies quantity limits per person. The output from the append table task is an arrangement of raw data that expands both vertically to account for each submission form and horizontally to account for any possible food category name changes. Thus, given the values for weeks 1, 2, and 3 shown in the previous slide, we now have a collection of 6 observations and 7 variables. For the fall 2020 reporting cycle, however, the raw data yielded over 1,200 observations and 57 variables. The next step is to create computed columns which can perform calculations or change values for the purposes of broadening the analytic power of imported fields. For example, the submission date field can be reformatted from text values to date time values so that SAS can perform additional calculations in a subsequent procedure. Let's see more examples like this to illustrate their applications in data analysis. Suppose we want to know the day of the week that generates the most submission forms. Well, first, to add a computed column, open the Query Builder wizard, click on Computed Columns, New, Advanced Expression, write the desired expression, and then Next. The expression requires 3 main functions. The compressed function removes specified characters. The put function performs a numeric to character conversion, and the date part function extracts the date from a date time value. So to create the weekday column, we need the variable date time, which is a formatted version of submission date. From there, we need to extract the date part, assign the appropriate format, and remove space characters. The output is Sunday, Monday, Tuesday, etc. In the next example shown, we want to extrapolate the Monday corresponding to the submission date. In other words, if it was submitted on Sunday, then we want to know Monday's date. If it was submitted on Thursday of that same week, then we want the output to still be Monday's date. To accomplish that, we need to use the intNX function, which will be explained further in the next slide. But what you should gather from this slide is that the numerals used in the logic statement correspond to the day of the week, with 1 corresponding to Sunday, 2 to Monday, and so on. Suppose that we want to segment submission forms not by the submission date, but rather by the date in which the form was activated for the week. So we create a computed column named Week Breakdown. The logic statement assigns 5 p.m. on Friday as the interval boundary. In other words, Friday, October 2nd is assigned to all the records shown if the datetime variable is between 5 p.m. on Friday, October 2nd, and 4:59 p.m. on the subsequent Friday, October 9th. Thereafter, the new interval begins with 5 p.m. on Friday, October 9th. Although creating computed columns can be extremely useful for organizing data in very specific ways, sometimes it's much easier to write code. In this regard, SAS Enterprise Guide is flexible enough to allow for this because SAS programs can be written directly from the same process flow. Suppose we want to quantify the total number of weeks, or TOTE weeks, that a student has submitted a form over the span of a semester. We can write code which will add up all the numerical values for columns that begin with week of. The operation is similar to the sum function in a computed column, but the advantage here is that it is not necessary to manually enter every single column name into the formula, thus saving time and effort. In our second example, the goal is to scrape the data for each student's first visit to the food pantry. After the data is sorted by ID number and then by the timestamp on the submission form, the data step creates the first dot variable, which is one of two temporary indicator variables stemming from the by group. It names the new column first visit date and assigns a format of 2-digit month, 2-digit day, and 2-digit year. Next, for all ID numbers that are not temporary indicator variables, SAS sequentially numbers them. The end result is 1 row per student per week breakdown, his or her first visit date, and freq of BNUM serving as the order in which the form was submitted. It is then possible to filter by the maximum value of freq of BNUM to show the year-to-date visit count per student, which would essentially yield the same result as the previous data step, where we created TOTE weeks. Recall that at the beginning of this presentation, I showed you how to use a pen table task to consolidate data. A similar result is obtained when using the merge statement in a program code. However, there is one key difference in the output. Instead of aggregating vertically and thus ending up with more than 1 row per student, records are matched by ID number, and the variables are spread out accordingly. Essentially, how match merge works is that if you have two files with a common identifier, then it will create a composite list of all the ID numbers and fill in values in the corresponding fields. Let's take a moment to recap. Using raw data from submission forms, CSV files from multiple weeks were imported into SAS Enterprise Guide. They were aggregated together using the append table task. Computed columns were created to add depth to input variables. And output data from SAS programs were merged. In the interest of time, we did not cover joining tables with institutional records. Nevertheless, demographics played an important role in understanding the population of college students that are food insecure. For the fall 2020 reporting cycle, project stakeholders were interested in exploring enrollment, educational level, residency, housing status, and measures for identifying underrepresented groups. As a side note, I want to point out that the process flow shown is a simplified version of the original. It is only intended to recap the topics covered thus far. After wrangling with the raw data in all sorts of ways, 4 types of variables were created. Those that were unchanged from their natural form, those that were calculated to provide depth to the data, those that were recoded to enhance organization. For example, food categories ending with IND were dichotomous variables to indicate whether the food category was selected or not. So 0 for no and 1 for yes. Food categories ending with CNT were continuous variables to encode quantity of food items specified in a text field. Such manipulation required a function that locates text patterns and ignores noisy data contained in parentheses or brackets. It was determined that the PRExchange function was suitable for capturing food items separated by commas. Finally, the last type, matched variables, were linked to institutional records. They constituted all the demographics of interest for fall 2020. Needless to say, without the proper analytic tool, much of this information would have gone unexplored. And that's where SAS Visual Analytics came in to help with making sense of all this rich data. One of the great features of SAS Visual Analytics is that it is intuitive enough to automatically make chart suggestions, therefore expediting reporting capabilities. But of course, it is also possible to create charts or graphs from scratch and to customize pages according to specific data needs and to comply with institutional branding. As such, the final report contained several key metrics. There were pages dedicated to the total service requests per month and week breakdown, the number of new users for each subsequent month of the semester, a comparison of students living on versus off campus, and a breakdown of graduate versus undergraduate students. Additional pages of the final report included a comparison between the proportion of users based on residency versus the proportion observed in the entire student population for the given semester. It was also important for stakeholders to know how many food pantry users were first-generation students or participated in the Educational Opportunity Program. It is worth noting that SAS Visual Analytics has interactive capabilities. It can be used to share the information dynamically by adding control buttons. These control buttons enable administrators to drill down on the data and offer the flexibility for on-demand reporting. Although the primary purpose of submission forms was to manage the distribution of food items to food pantry users, the data served broader uses. With the assistance of Student Affairs Assessment, the Binghamton University Food Pantry was able to launch a survey in late December to determine how the onset of the pandemic has affected users. And an infographic was created to compare usage between fall 2019 and fall 2020. In addition, the data has provided the necessary information for grant proposals. Thank you for tuning in. I hope you found the presentation informative, and I hope to connect with you soon. Take care.